Hello, everyone. My name is Mark Ryland. I'm the Director of the Office of the Chief Information Security Officer at AWS. Welcome to the Amazon Web Services Financial Services Cloud Symposium. Sorry I can't be with you there in person, but it's good to be together virtually. I hope your day is going well, and I look forward to talking to you for a little while about a very important topic, namely cloud security. In particular, our topic of the day is top 10 security things to do. Do 5 now, or very soon, and keep going on some of the others. Before we get to that more specific topic of a very good checklist that customers have asked for, I want to step back and talk briefly about the broader topics around cloud security. We like to say that security is job zero at AWS. It sounds like a little bit of an odd phrase, but what it means is even before we get to priority 1, there's priority 0. It comes before everything else. It means that we focus our energies very, very heavily on security, designing for security, constant monitoring, highly automating our systems. We operate at such a scale that we have to use automation, and that provides consistency and lots of other nice security properties. Our systems are highly available, highly scalable, and they allow you to build, in turn, on top your highly available and scalable applications as well as your highly secure applications. And finally, we are highly accredited. What I mean is we operate under dozens of compliance regimes where third-party auditors closely scrutinize what we're doing, ensure that we're doing what we claim to be doing, compile evidence, write reports, and then you as a customer can access those compliance reports, and you can be assured and pass on to those who need assurance from you that we're doing the job that we claim to be doing. So we're very proud to be supporting lots of compliance work. It's just a normal part of our work, and it keeps us on our toes, and we do a lot of it, and so you can really rely on that. Another really important aspect of cloud security is the notion of shared responsibility model. What this means is we'll take care of a lot of the things that you normally have to worry about in your on-premises environments. If you look at a large control framework like a NIST 800-53 security control framework with 230 or so security controls, if you enumerate those and go through that long list, you'll find that the cloud will completely take care of a large number of those, maybe 25-30%. There'll be another 20 or 30% that we do some and you need to do some, and then some percentage that is more on your side of the responsibility boundary. But the point is, your security experts, while they still have work to do, and you can't be sloppy, you've got to do a good job, but they have a lot less to worry about. They can be much more effective because we've reduced the scope of the things they need to be concerned about. So the net effect of this shared responsibility model, while you still have responsibility, is you have more capability to execute on the things you need to do. Another important point, however, is that this responsibility model is not static. It's dynamic, and it's dynamic in your favor. And what I mean is, over time, we add more features, more high-level capabilities, services that have more things built in that you don't need to worry about. And while you can always get access to very low-level, powerful, flexible features, you can also begin to access these higher-level platform services where we take care of more and more things automatically, and you just upload your code and upload your data, and you're always going to have some responsibility. It'll never be zero. You need to properly understand and configure things, but you can really reduce the work you need to do by using the services that we provide, and we constantly improve over time. So let's get to our top 10 list. So a little background on the top 10 list. We first gave this presentation, one of our leaders, my boss actually, Steve Schmidt, who's our CISO, at our conference last fall in Las Vegas, the reInvent conference. And what had happened in that case was he went to our organization and said, hey, what are the top 10 things? People like checklists. They want some, well-vetted, validated, fairly easy to consume information that they can just check through and make sure they're doing the basics. What are those things? And so we went to our experts that work with customers all the time. We went to our field teams, our solutions architects, technical account managers, professional services. These are folks that help you every day. They also run a really cool process called the well-architected process, where we essentially do a free best practices review around reliability, cost efficiency, etc. But one of the pillars of well-architected is security. So the feedback from working with customers on well-architected was an important ingredient in coming up with our top 10 list. Our support teams work with customers every day. They're on the phone, they're on the emails, they're on the chats with customers looking for help. And by surveying them, we also got a good set of insights into what are the most important things and the most foundational things for customers to keep an eye on. And we also looked at some events our customers have had. So sometimes customers do have a bad day, and we do our best to minimize those, as do our customers. But based on some things that have gone wrong, we've also developed some good understanding of things to avoid. So based on this kind of input, we came up with the top 10 list. So let's take a look. We call this 10 places your security team should spend some time. And we're going to go through each one of these, but in kind of a funny way. I'm going to actually go through 5 of items on this list rather quickly. These are 5 that take a bit more time and that will be more of a process for you. And then I'll spend the bulk of our time on, let's say, the most straightforward or easiest 5. So we'll kind of do this in reverse order. I'm going to quickly go through, you could say, the little bit more challenging ones, and then we'll spend a bit more time on the easy ones, and we'll come back together, especially around this item 10, get involved in the dev cycle. This is a super important thing that kind of ties together the 2 wings of this list. So let's start with quickly going through the 5 that we're going to cover quickly. So number 3, and first on our little bit more challenging list, no hard-coded secrets. So again, we won't spend a lot of time on some of these. They're fairly technical, but for your engineering leaders and developers in the audience, you know that when you write code these days, you have to call other code. And so our source code needs to be able to compile or be interpreted down and make access calls to databases, to other APIs, to NoSQL databases, object stores, all kinds of things. And in many of those cases, you have to authenticate somehow the code to another piece of code. Historically, we've followed bad practice. In a lot of cases, we would put those passwords or those secrets directly in the source code or in a configuration file and check them into a source repository. If that was all that we had at the time, well, it's not a good idea because it's really hard to manage those secrets once they're out in those public places, but it may be the best we have. But that's no longer necessary. In the cloud, we have a bunch of features, a bunch of services that make it very, very easy and straightforward to put your secrets in a safe place and only extract them right before use, and also to automatically rotate secrets, such as database passwords, so that even should secret leak for some reason, it will not be harmful to be out there for more than a relatively short period of time. So that's a very important thing to keep in mind as you go on your cloud journey. Intentional data policies. Again, this is a bit of more of a long-term challenge. Many companies are already good at this. Many government agencies, they have a well-understood data classification of data from public to mildly sensitive to very sensitive, etc. But it's just important to be very conscious. That's what we mean by intentional data policies. Very conscious of what data you consider most sensitive, moderate sensitivity, and then less so, and then treat them accordingly with more rigorous controls, much more restricted access, least privilege, etc. The more sensitive the data is, the more carefully you need to handle it. And that's very important to do well in order to be successful in any IT environment, and certainly in the cloud. This is, again, a sort of technical one, but your security teams, our customers operate with multiple accounts, multiple teams, sometimes within an account. CloudTrail is a service that records all of the API calls that you make into a central stream. But if you're operating in multiple accounts, you might end up having lots of these log streams. And our customers who are most successful with cloud security, what they do is they use a feature of this service to put all of the logs in a central place, put the right access controls around that and the right archiving. And that central management of all that important security logging information really comes in handy as you go about operating in the cloud. Validation of IAM roles, very important topic. We won't spend more than a few minutes, but super important. This means that when you create the privileges around different types of principals or users or roles in the AWS environment. You got to be careful and make sure those are well defined, well documented, that there's good change control around those. It's a super powerful, super flexible system, but it has to be treated carefully because this is what actually permits people or software to access different aspects of the cloud environment. So again, this is your basically access management element of your cloud journey. And finally, in our run through of 5 of these 10, rotation of credentials, secrets, keys, passwords, very important. It's a best practice wherever you are in the IT world. Very important in the cloud, and fortunately the cloud again gives you lots of capabilities that include things like the use of only temporary credentials, automatic rotation of secrets in our secrets manager service. There's lots of good things to do here, but you have to set it up and configure it and use those features. So that's quite important. So let's move on now to some of the other items. These are a little bit more, do these right away, not too difficult. And that's how we'll focus the majority of the rest of our time in this presentation. First of all, accurate account information. This sounds really simple, and it is really simple, but you really need to maintain with us the correct email and phone number so we can reach you. You'd be surprised how often we have things we want to tell our customers. We notice a problem. We see something that looks anomalous. Someone complains about something. Maybe there's a system that's been owned in the environment and is beaconing out some malware or port scanning. We need to be able to reach our customers, and generally can, but surprisingly often it's very hard to reach customers, and that's just a very, very fundamental thing. Have correct email on file, have a working phone number. These are also very important from a security perspective because we'll talk about multi-factor authentication in a second, but this is how you configure MFA, how you do MFA reset, how you prove that you have ownership of an account. Keep these things accurate and up to date. Another very important point is that the root principal, sort of this very powerful user in an AWS account, is a very important security property. That's a very powerful capability. It's the most powerful administrator. It's important to maintain a lot of security around that principal, and in particular, have multiple trusted administrators jointly getting access to the control around that email address and the associated security properties. At a minimum, use a distribution list. That way, if you have an employee that leaves or there's some change in administration, etc., you can put the new administrators onto that distribution list, remove the old ones, and still maintain contact with AWS because we're going to send emails to that email address, and sometimes those will be very important emails. Better than a distribution list is to have some kind of shared inbox with forwarding rules. That way, there's one place that the privileged users can go to see a complete set of all the emails we've sent, but also because of the forwarding rules, they don't have to pull that email all the time. They can essentially be notified when a new email comes and then log in and check that email. You need to control access to all this email very carefully because, again, this is a powerful principle, and things like password reset, MFA reset, other kinds of changes in the account will be noted, and we will send an email saying, hey, someone just asked to make this change. Is that okay? Or other kinds of validations, and you need to be paying attention to those. So it's very simple, it's very straightforward, but super important to maintain, valid contact information and good security around the root principal and that associated email address. We have other contexts you can put in to our system for security contexts, billing, operational context. Those are also important. Not quite as critical as that root principle, but quite important, and you should use similar capabilities and care around that. These are also very good detection points for your security team. So we'll send things like billing alerts, if there's an unusual billing event, or you can set up alerts that say, hey, email me every time my monthly bill, increments past this amount. And that actually can be very useful. If you see lots of unusual usage, the bill will increase, you'll get an alert, and that can be an important signal for keeping your account safe and secure. Item number 2 on our 5 to do right away list, and that is use multi-factor authentication. Very simple, surprisingly not done all the time. You want to put an MFA token of some kind on that root principal. It provides that extra layer of protection in case there's any type of compromise of the name or the password. You can do this for the root principal. You can do it for a type of principal called an IAM user. All those would be strongly recommended. You can use for that virtual MFA devices, meaning something like that works on your cell phone. You can use U2F security keys. These are very inexpensive and easily obtained, and they work great. We have hardware MFA tokens you can buy from us. They cost just a few dollars and work quite well. We've also been beta testing an SMS-based MFA capability. There's some challenges in the SMS space because of things like SIM cloning, etc. So it's probably not a best practice, and we're still working on making this a final product and working with customers to determine just what to do with it. But I would say of these, I would recommend probably for most of you the virtual MFA device approach, because among other reasons, this allows you to have, again, multiple privileged admins that do have access to the root account, but also should one leave your company, or should a virtual token get destroyed, what have you, you can actually recover these. And this is a way to share the responsibility across a privileged set of administrators. Now, a lot of our customers use identity federation, which means that they don't authenticate directly to the AWS systems at all. They come in after authenticating to Active Directory or Okta or some other identity service. They bring their SAML token or their OAuth token to our platform and exchange that for our security token, and then begin to use the APIs. That's a very reasonable and probably best practice kind of thing to do. But in that case, the MFA approach is a little bit different. In that case, you're going to do your MFA with your identity provider, and that will be part of your authentication dance on that side. And we, as a relying party, will then take those incoming claims and process them accordingly. One of the nice things about our work on the MFA front is we've recently added the ability, even when you're using our command line interface, which a lot of your engineers and developers are going to want to use, you can still use temporary tokens, federation, and MFA in order to authenticate your users, which is really great. So number 3 on our list and number 4 in the top 10 list, we're going to switch from identity management and authentication, authorization, and those topics. We're going to switch to networking and look at network security. And that is a very important, very simple feature built into the platform, but surprisingly not always used effectively, and that is our security group feature. So in this case, when you're running in our virtual machine service, or you're using our container services or our Lambda compute service, basically any compute service, we have this built-in capability to create what look like firewall rules, but they're much easier to manage. They're not literally a firewall, but they're actually firewall-like rules that get applied automatically to any compute environment that you put inside these notional objects that are called security groups. So you really want to pay attention to these. There's always one there. You can't run a compute node without a security group, but you want to make sure that you configure it carefully. And also you want to be very leery about having public access to your compute environment. Now, of course, there's valid reasons to have public IPs in some cases. That main access point for a web-based application might well be public, but for those people working on your systems, you should really avoid the convenience, but the sort of dangerous one of giving public IPs to all of your compute nodes, your EC2 instances, because it's just going to cause some challenges. And if people are not careful, something can go wrong. So instead of connecting to the internals of your cloud systems using public addressing, use a bastion host, which is like a way to sort of tunnel into your environment, or create a client VPN connection. We have a great service for client VPN where you can take any Windows or Mac machine or Linux machine. You can tunnel into your private virtual private network, your virtual private cloud VPC environment in AWS, and your engineers and developers can be inside that private environment, connecting securely and in an encrypted fashion over the internet, and no outsider can easily get access to those systems. We also have a even cooler service we call Systems Manager, Session Manager, where we have a service that's focused on secure access without any public use of any public IPs in your environment to your hosts. So I strongly suggest you take a look at that. We also have a feature called EC2 Connect, which has some of these same properties. A lot of ways to do this. The main thing is really, be careful in terms of what's accessible from the internet. If you have to have an IP address, a public one on an instance, lock it down and give very limited access to that instance. When you do need public IPs, and there are times when that's completely appropriate, make sure that it's more for, you might call, hardened interfaces, the web interface for web application and so forth. Avoid opening any of the ports that go into a more back-end type system. You shouldn't have open ports for SSH or RDP, MySQL, Elasticsearch. These are mistakes we see pretty often that customers make, and not always with a happy ending, so be careful. It's very easy not to do this, but you have to just be aware. If you open up any of these systems to the public internet, you're really asking for trouble. But fortunately, it's very easy to avoid doing that. That's why we have this checklist. You can't even scan your public IPs just to see what others can see. That's not a bad practice, and in fact, very recommended. So keep that in mind as well. Now, even inside your virtual private cloud, so now you're in a completely private network. There's no way for someone to get from the internet into this network, but even there, security groups allow you to create very locked down parameters around what servers can talk to what servers. So you can create very simple rules that say, look, this web front end, my load balancer can only talk to the web tier. The web tier can only talk to the application tier. The app tier can only talk to the data tier. The data tier cannot talk back to the app tier or to the web tier. The web tier can't talk to the data tier. It's very simple and straightforward to use security groups in our VPC environment to create those kind of rules at the network layer that will prevent potentially a problem if for some reason something goes wrong on one of those servers and some bad actor, for example, is able to get access. You've greatly limited the harm they can do if you use security groups to limit the access for those systems. And finally, we have a service called Firewall Manager that makes the security groups even easier to manage, because you can write essentially security group policies and manage a large number of security groups across a bunch of VPCs, across a bunch of accounts, using rules that are applied automatically. So for large-scale deployments, you should seriously consider Firewall Manager. Let's move on to our fourth item in our quick 5 list, shall we say. Now, when this presentation was first given, we had this item, take action on guard duty findings, but times have changed and we have more and more services besides guard duty that give important security findings. So let's kind of update this slide. So we have guard duty, which is our intrusion detection system. It gives you all kinds of important alerts on things in your environment that may not be going the way they should. But we've added a number of other security capabilities over the last year and a half. Things like Access Analyzer to do an inspection of your roles, your IAM principles, and make sure that those are configured in a safe and sane fashion. We have Amazon Inspector, which does analysis of your compute nodes for things like CVEs and other kinds of software errors or updates that need to happen. Amazon Macy is our system which does detection of different kinds of data that you may have and helps you classify data and discover if you have sensitive data in a place where you would prefer not to have it. And then finally, an important launch from late last year is our new service we call Security Hub. And Security Hub is a really important service going forward because all these services create security findings, and you really want to be able to access those in a more central fashion. And so kind of in the end state, all of the services will emit their findings into Security Hub. And you can see the overview and analyze and warnings, and you can automate responses to these warnings because everything arrives as an event which can be programmed to then create automation and response. All that can be done using Security Hub as kind of the single pane of glass for understanding what's going on in your AWS environment from a security perspective. One thing that's really important here, and it's a general problem in the security industry, and it's no real easy answer here, but there is this challenge that sometimes you see alerts and warnings and maybe some false positives. We try to minimize those, but they do happen. And it's tempting sometimes to just suppress those warnings and say, hey, just don't bother me with that one again. But we really recommend you don't do that. You should develop some tools and some automation around that to deal with those, but sometimes those warnings are really important, and you shouldn't ignore them. So develop some skills and some best practices around dealing with alerts, and make sure that you don't suppress alerts, which might end up saving you at some point. Now, finally, the most important point really of this whole presentation, and it goes across both the quick 5 list, if you will, and the more challenge, the 5 items that take a bit more time. This one does take time, but I'm putting it in the top 5 list because it's so important. You need to start this right away. If you look at the traditional, engineering cycle for IT, for software development, for infrastructure, you have a business owner. They need stuff to get done. There's a development team, an operations team, and a security team. And they have somewhat different and competing interests. The business team says, speed up delivery. I need better capability faster. I've got to be competitive in this market. I'm a government that's got to deliver citizen services, to a citizenry that expects, high quality services. The developers feel the pressure. They write the code. They do a decent job. They kind of throw it over to fenced operations. Notice that there's a little bit of a mismatch of incentives here, because if the developer is not operating their service or their code, then it's not quite as painful as it would be otherwise for there to be bugs in that code. Not that anyone, of course, intends that, or that they don't do their best, but still, the truth of the matter is, their page, they don't have a pager going off in the middle of the night, typically in traditional waterfall type software development. If something goes wrong, that's the operations team. They're the ones that are cursing the bugs and dealing with them in the production environments. And similarly, security has a kind of different incentive too, which is both operations and security. Let's minimize changes. Changes cause trouble, so they both are incentivized to minimize change, while the business and side and the developers responding to that are trying to hurry up and deliver as much as possible. We've all seen this kind of pathological case, and we all know that there's a better way, which we now call secure DevOps, and that is where the business interests get more closely aligned and you integrate the development, operations, security into a single functioning team that has different skills and different emphasis in how they work and different points where they work in the pipeline, but overall it's a much more integrated process. And so that brings us to what we can call the modern automated software factory, the continuous integration, continuous delivery type of capability, where you have a source control system. Now, obviously, there's humans operating this, but the point is to get the humans out of the way as much as possible. They build this automation system, and then they write the source code, they check it in, automated tests run, automated builds run, automated testing and staging happens. Of course, software engineers built all these things, but once they're built, they run automatically. And then finally, in the most sophisticated systems, once the staging and testing checks are passed, the code will be pushed live to production without any human intervention. Now, sometimes you will have, for major changes, a bit of a more careful process where humans at least are supervising. But in principle, and often in practice, this whole cycle can be automated. And the maintenance process is not a separate thing. It's a go back to the source code and make the necessary changes to change and operate the service. In other words, operations doesn't occur as someone logging into a box and making a manual change. Operations is a function of changing the source code and running the whole pipeline again to remove some operational issue or bug. Now, you can still have emergency, break glass where someone can log into a box and make a manual change, but that you try to avoid that as much as you can. And security is now part of this CI/CD pipeline as well. Your security engineers are part of your daily stand-ups. They are involved in building their security checks into the source control system, the build system, security canaries, which run against the production system, automating everything as much as possible, and being a core part of a team of integrated engineers that have the software development skills, the operational skills, and the security skills to together build and operate this modern software platform, this automated platform to deliver high quality software and develop and improve it at a very, very high rate of speed. notice this is not just your applications, but in the cloud, because the cloud is programmable fundamentally. Everything in the cloud can be controlled and operated by software. So it's your infrastructure as well that is managed in this exact way. And that really leads back to this important message, which we'll close with for your security teams, which is get involved in that development cycle. Develop bring software engineering skills into your security team, bring your security team into the software engineering process. And of all the items listed in the top 10 list, many of these are essentially ongoing efforts that will never stop. So things like making sure you don't use hard-coded secrets, automatically provisioning and maintaining your security groups, centralizing the analysis and so forth of your security logs, validating IAM roles, taking action on security findings. These are all things that you'll never stop doing, but in this modern secure DevOps fashion, the security team will play their role in a very, very different way. So in closing, I'd like to thank you for spending time with us and with me today. I think you'll find that by using the AWS cloud, you can really raise the bar, working with us to build and deploy very sensitive applications, highly secure, highly available, highly scalable, deploy and run and manage those in the cloud, and gain a lot of the efficiencies and a lot of the security that we see across our customer base. And I hope you are on this journey with us, or will come with us on this journey. And together we can build and deploy and maintain some great systems, meeting our business needs, meeting the needs of citizens if you're a government agency, meeting whatever needs there are for your organization using the AWS cloud. Thank you very much for your time. I really appreciate you spending time with me today. I hope this has been helpful. You have lots of resources in your field sales and ProServe and support organization at your disposal, so reach out to your solutions architect, your sales account manager, and they'll help you go deeper on all these topics. We have lots more material, papers and workshops and so forth. Take advantage of those things and work with us to have a very successful journey to the cloud. Thank you very much.